Let's go to page 322 and start with number 489. Okay, so probability of the rain on any day in Atlanta is 20%. Okay, so in this case, not raining. Okay, let's see. Okay, and after how many days you would expect to have a rain on 30 days? So again, remember, expectation is the probability times number of the numbers, right? So you're going to get 0.2 times n, and this will give you expected value of 30. Okay, 0.2. Okay, so to solve, you divide by 0.2. So n will equal to 150 days. Okay. So again, in 150 days with probability of rain of 0.2 or 20%, you're going to expect to have a 30 raining days. Yeah, let's go to number 490. Okay, number 490, it says what's the probability of a player getting a hit is 310. Okay, so probability of getting a hit is 310. From the probability that he gets 2 hits in 4 at bats, okay, in her next game. So again, this is expected value. Now, there are many ways you can have the hits. So you're going to get 2 hits in 4 bats. Okay, so you can have the hit, miss, or miss, right? Or I'm going to use M for miss. Okay, and so you can have H, M, H, M. You can have the H, M, M, H, right? And then after that, you can have the M. You can have H, H, M. You can have the M, H, M, H, right? Then you can have M, M, H, H. So there are total 6 scenarios, right? And now we can do this is that this would be the 4C2, right? So this is 4C2. There are 4 chances and going to get 2 hits, okay? But anyway, so there are 6 scenarios, right? So the 4C2, so you choose one of the scenario, and each one of the scenario you have to times it by 3 of 10. Let's say if you do this one, okay? So it'd be 310, 310. So 310 is hit, and then you have miss would be 710, and not getting a hit, okay? And so probability, if you work it out, so we already did this over here. This is 6, okay? So 4C2 would be 6 times all these numbers. So if you just go and use the calculator, work it out, you get 1325 over 5,000. Okay, let's go to 491. Okay, 491 is a 2 digit between 1 and 9 inclusive. Okay, inclusive means you include the numbers, so 1 to 9 inclusive. Select the random. Same digit may be selected twice. What's probability the product is a multiple of 3. Okay. Okay, so probability that the product is multiple of 3. Now, there are too many cases. So what you want to do, that in order to be multiple of 3, one of the number would be multiple of 3, right? So you want to do the none. Okay, so it's not multiple of 3. So if the 2 numbers are not multiple of 3, then neither is the multiple of 3. So what you want to do, you want to find neither. Okay, so neither is multiple of 3, and this will equal to not multiple of 3, right? So again, if you look at the digits, so if you count them, so it'd be 1, 2, 4, 5, 7, 8, right? So there are 6 of them. Okay, so neither is multiple of 3, so there are 6 choices, right? 6 times 6 give you 36. Okay. And therefore, and the total, okay, so the total is, the sample space for the two number would be 9 times 9 equal to 81. Okay. So the one you're looking for, so the one you're looking for would be, the probability you're looking for would be 81 minus 36 over 81, right? So again, this is what you don't want. So total minus what you don't want to get what you want, divide by the sample space. And this will equal to 45 over 81. And so probability will equal to 5 over 9. Okay, let's go to next one. Okay, go 492. 492, it says, if 5 standard fair dice are tossed simultaneously, what's probably the outcome has sum greater than 28? Okay, so you want to have a sum greater than 28. Okay, now when you roll the 5 dice, right? So greater than 28 would be this way. That means you have to sum would be either 29 or 30. Okay. So this is not too bad. Okay, so to get 30, you have to get all 6. Okay. Okay, so that means there's only one way. So you have to know how to count. To get 29, okay, that means one of them had to be a 5. Now, there's going to be 5 ways. Because the 5 can be here, 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 right? And you can list them, right? You can do it this way, right? So you can see that, okay, so there are 5 ways. So that means the total would be 6 ways. So the probability would be, there are 6 ways, and the total sample space would be 6 to the 5 power, because this one has 6 choices. This one, the first die has 6 choices. So each die has 6 choices. So there are 5 of them. So it'd be 6 times 6 times 6 times 6 times 6. Okay, and so this will equal to the 1 of the 6 it can also be 1 over 1296. Okay, let's go to 493. Okay, so you have 8 first graders, so 4 girls and 4 boys, and arrange himself randomly around a merry-go-round. So merry-go-round is a circle. Okay. So there are 8 people around the merry-go-round. Okay. So what's probability that boys and girls would be seated alternately? So what you need to do is you have to use one of the person to fix, because remember it can rotate, right? So you have to use one of the person to fix it. So I'm gonna make this as a girl, okay? So once you fix it, okay, so now this one is already fixed, okay? That means you got 3 girls to to do different combination, okay? So probability would be equal to 3 factorial, okay? So again, one is used to fix, and the other 3 would be you're able to to see it differently, okay? Now the boys, there would be 4 factorial. Again, imagine these are the places for them, right? So 4 boys can do any of the any of the permutations. Then you have to divide it by the sample space, the total. Remember, one person is used to keep it from rotating, right? And so you got 7 people left, so that'd be a total. Okay, and so this will equal to, now this and this will cancel out. So remember, 7 factorial is 7, 6, 5, 4, 3. So so it will be 7, 5, 7, 6, 5, and all the 4 will cancel with a 4 factorial. So it means you only get 3, 2, 1 over here. Okay. Again, if you write it out, this is what you're going to get: 4, 3, 2, 1. That's your 7 factorial. So 4 factorial would be 4, 3, 2, 1. And so this would be all cancel out. So you're going to get that. Okay, so 3, 2 cancel with a 6. So probability would be equal to 1 over 35. Okay, let's go to the next one. Okay, so 494. A secretary write letters to 8 different people, address 8 envelope with the people's address. Okay, so okay, and he randomly put letters in the envelope. What's probably that he get exactly 6 letters correct and in the correct envelope? Okay, so the 6 of them, so they are total of 8. So you choose randomly. So probably would be, so there are 8 of them, and you want to choose 6 of them to be correct. Okay, so let's say this 6 is correct. Now the other 2, there's only one way of getting it incorrect because it means that letter got switched, right? So there's only one way for the other 2. Okay, and you divide by the total number of ways. So it's 8 factorial. Okay, and so you simplify these. Okay, so this one, so AC6 is equal to, is same as AC2, and this will equal to 2, 1, 8, 7, so it cancel out. So it would be 28 over 8 factorial. And so if you simplify, let's just write this down. So 4 and 7 cancel with that, and so you're going to get 1 over, and you multiply all this out. Okay, so multiply 2 and 5 give you 10, and multiply this and everything, you get 1440. Okay. Okay, let's go to 495. Okay, 495 is an integer from 1 through 10 inclusive. Partition at random to 2 sets of 5 elements each. Okay, so you got 5 numbers each. Okay. So what's probability 1 and 2 are in the same set? So if you put 1 over here, now the 1 and 2 are the same set. So it's going to be, for the 2 to be in here would be 4. There are 4 of them out of 9. Right? Because again, there are 9 places that number 2 can be. Number 2 can be here, 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 anywhere, right? So there are 4 here versus the whole thing, right? You want a 2 to be over here to same set as 1. So the event is 4, the total is 9. So probability would be 4 over 9. Okay, let's go to the next one. Number 496. Okay, so we did this kind of similar problem before, but this one is a little bit slightly similar. Okay, so you have the 4 people. You got A, B, C, D, and this one they're rolling the dice. Okay, so if they roll 8 or 9, they lose. Okay, and so you want to find out the probability that duck survive. Okay, now if you're going to find the duck survive, it's complicated because you have to find out that the A did not survive, or B did not survive, or C did not survive, so to complicate. So what you want to do is you want to find out D, the duck did not survive. Okay, so D walk the plank. Will equal to, okay, now you have to figure out the probability of 8 or 9, right? So to get the 8, you get 6, 2, 5, 3, 4, 4, 3, 5, 2, 6. So there are 5 ways. 5 ways for getting the 8. And the 9s would be 6, 3, 5, 4, 4, 5, and 3, 6. Okay, so there are 4 ways. So probability of getting the 8 or 9 would be equal to total of 9 out of 36, so it would be 1/4. Okay. Okay, so 1/4 means they survive. Okay. Okay, so so 1/4. If a person rolled 8 or 9, means did not survive. So for Doug to walk the plank means he survived. Means these 3 people survive. Okay, so survive would be 3/4. That's for A. And then this one, the second person also survived, would be 3/4, and he survived would be 3/4. And then Doug did not survive, so it would be 1/4. He wrote 8 or 9. Okay, so probability of walking is equal to, your multipliers would be 27/256. Okay, so probability of Doug survive will equal to 1 minus 27/256, and so equal to 229/256. Okay, let's go to 497. Okay, instead of using 2 standard cubical dice in the board game, the 3 standard cubical dice are used to the same game to make the game go quickly. In the regular game, doubles are needed. Okay, so probability of the odd one. Okay, double is equal to. Okay, so I needed to draw the pit. Okay, so a double would be like 1, 1, 2, 2, 3, 3, 4, 4. So there's total 6, right? Out of 36. Okay, and probability of the new, okay, would be of the double or triple. Okay, would be 96. Okay, there are 96. So what you do is so to figure out this one, 96 is a bit complicated. What you do is you want to roll 3 dice with no duplicates. Okay, so no duplicates for 3 dice. So the first dice you can roll any number, so there's 6, right? And the second die cannot have same number as the first one, so there's only 5 choices. The third die cannot equal to any of these, right? Or else you're going to get double, right? So it'll be 4 choices. So no duplicates, okay, or means no double or triple equal to 120, okay? And therefore the double or triple would be 6 to the 3 power equal to 216. So 216 minus 120 equal to 96. That means this would be a double or the triple. Okay, so that's where the 96 came from. And over 216. And now you have to compare this with this. Okay, and so that's going to make into common denominator. This would be 36 over 216. So this over that. So the ratio will equal to 96 over 36. So it would be equal to 8 over 3. So it's almost triple the likelihood of getting out of the pit. Okay, let's go to 498. Okay, so 498, you're playing the risk. Okay. Okay, so Rocky rolled 1 die, and then Boingo roll 2 dice. Okay, so you want to find out the Rocky would be able to match that. Okay. Okay, so let's say Boingo, the highest Boingo equal to 1. Okay. So this one has only 1 choice, means 1, 1, right? And so the probability would be, so rolling 1-1 would be 136, right? And then Rocky to win had to roll 1, and obviously any number on the die would be greater or equal to that, right? So it'd be 6. Okay. Now when Boingo equal to 2, so this would be, you can roll 1-2 or 2-1 or 2-2, right? And so the probability will equal to 3, 1, 2, 3, 3 out of 36. Okay. And now the Rocky had to at least 2 or better, so it'd be 5, 6, right? So this is for Boingo, this is for Rocky, okay? And then when Boingo equal to 3, so it'd be 3, 1, 3, 2, 3, 3, 1, 3, 2, 3. Okay, and so this will equal to 5 out of 36. And then so again, this is for Boingo. Now for Rocky to win, you have to at least a 3 or better. So you got 4 choices, right? 3, 4, 5, 6. So it'll be 4 choices. Okay. Now Boingo equal to 4. So you're going to get, again, you can list them. It would be 7, 36. And now Rocky had to roll 4, 5, or 6. So it'll be 3 out of 6. Okay. And for Boingo, the highest number is 5. Okay, would be, again, you can list them. There are 9 of them. And for Rocky to win, you have to roll 5 or 6, so it'd be 2 out of 6. Okay. And then for the highest number for Boingo is 6. Again, you can list them. There are a total of 11. And then now Rocky have to roll a 6, so it'd be only 1 choice, right? Okay, so you add all this together, then probably it would be equal to 91 over 216. Okay. Okay, for number 499, again, so there are 20 minutes over here. And so you want to break it up. Okay, so the probability, so what you do is you want to, for no cards, it's very hard to find if there's a card. So you can, if you do it straight, it can be a card over here, card over here, card over here, or card over here, right? So it's better to do the opposite, right? So what you do is let P equal to C card in 5 minutes. Okay, and so not would be 1 minus P. And so you want to so you want to do the not seeing. Okay, so that means would be 1 minus P to the 4th power. Okay, so here you have to multiply, right? And this will equal to the seeing. Okay, so this is seeing, and so you have to subtract to figure out the not seeing. Okay, so again, this is seeing. This is probability of seeing a card over here. So you have to subtract that to figure out the probability of not seeing. And so this will equal to 16 over 625. Okay, so again, this is seeing, and this is, so this will give you, this is the total. And so this will be not seeing. Okay, and so this will equal to that. Again, remember this is not seeing, right? And so this will equal to 16 over 625. And then you can take the 4th root. So 1 minus P equal to 2 over 5. And therefore P equal to 3 over 5. Okay, and again, so this one you have to use a complement twice. Okay, over here and over here.